Chapter 1, Exercises. 1.1. Chemistry in Context. 1. Explain how you could experimentally determine whether the outside temperature is higher or lower than 0 degrees Celsius, 32 degrees Fahrenheit, without using a thermometer. 2. Identify each of the following statements as being most similar to a hypothesis, a law, or a theory. Explain your reasoning. A. Falling barometric pressure precedes the onset of bad weather. B. All life on Earth has evolved from a common, primitive organism through the process of natural selection. C. My truck's gas mileage has dropped significantly, probably because it's due for a tune-up. 3. Identify each of the following statements as being most similar to a hypothesis, a law, or a theory. Explain your reasoning. A. The pressure of a sample of gas is directly proportional to the temperature of the gas. B. Matter consists of tiny particles that can combine in specific ratios to form substances with specific properties. C. At a higher temperature, solids, such as salt or sugar, will dissolve better in water. 4. Identify each of the underlined items as a part of either the macroscopic domain, the microscopic domain, or the symbolic domain of chemistry. For any in the symbolic domain, indicate whether they are symbols for a macroscopic or a microscopic feature. A. The mass of a lead pipe is 14 pounds. B. The mass of a certain chlorine atom is 35 AMU. C. A bottle with a label that reads Al contains aluminum metal. D. Al is the symbol for an aluminum atom. 5. Identify each of the underlined items as a part of either the macroscopic domain, the microscopic domain, or the symbolic domain of chemistry. For those in the symbolic domain, indicate whether they are symbols for a macroscopic or a microscopic feature. A. A certain molecule contains one H atom and one Cl atom. B. Copper wire has a density of about 8 grams per centimeter cubed. C. The bottle contains 15 grams of Ni powder. D. A sulfur molecule is composed of 8 sulfur atoms. 6. According to one theory, the pressure of a gas increases as its volume decreases because the molecules in the gas have to move a shorter distance to hit the walls of the container. Does this theory follow a macroscopic or microscopic description of chemical behavior? Explain your answer. 7. The amount of heat required to melt 2 pounds of ice is twice the amount of heat required to melt 1 pound of ice. Is this observation a macroscopic or microscopic description of chemical behavior? Explain your answer. 1.2. Phases and classification of matter. 8. Why is an object's mass, rather than its weight, used to indicate the amount of matter it contains? 9. What properties distinguish solids from liquids? Liquids from gases? Solids from gases? 10. How does a heterogeneous mixture differ from a homogeneous mixture? How are they similar? 11. How does a homogeneous mixture differ from a pure substance? How are they similar? 12. How does an element differ from a compound? How are they similar? 13. How do molecules of elements and molecules of compounds differ? In what ways are they similar? 14. How does an atom differ from a molecule? In what ways are they similar? 15. Many of the items you purchase are mixtures of pure compounds. Select 3 of these commercial products and prepare a list of the ingredients that are pure compounds. 16. Classify each of the following as an element, a compound, or a mixture. A. Copper. B. Water. C. Nitrogen. D. Sulfur. E. Air. F. Sucrose. G. A substance composed of molecules each of which contains 2 iodine atoms. H. Gasoline. 17. Classify each of the following as an element, a compound, or a mixture. A. Iron. B. Oxygen. C. Mercury oxide. D. Pancake syrup. E. Carbon dioxide. F. A substance composed of molecules each of which contains 1 hydrogen atom and 1 chlorine atom. G. Baking soda. H. Baking powder. 18. A sulfur atom and a sulfur molecule are not identical. What is the difference? 19. How are the molecules in oxygen gas, the molecules in hydrogen gas, and water molecules similar? How do they differ? 20. Why are astronauts in space said to be weightless, but not massless? 21. Prepare a list of the principal chemicals consumed and produced during the operation of an automobile. 22. Matter is everywhere around us. Make a list by name of 15 different kinds of matter that you encounter every day. Your list should include, and label at least one example of each, the following: a solid, a liquid, a gas, an element, a compound, a homogeneous mixture, a heterogeneous mixture, and a pure substance. 23. When elemental iron corrodes, it combines with oxygen in the air to ultimately form red-brown iron, oxide called rust. A. If a shiny iron nail with an initial mass of 23.2 gram is weighed after being coated in a layer of rust, would you expect the mass to have increased, decreased, or remained the same? Explain. B. If the mass of the iron nail increases to 24.1 gram, what mass of oxygen combined with the iron? 24. As stated in the text, convincing examples that demonstrate the law of conservation of matter outside of the laboratory are few and far between. Indicate whether the mass would increase, decrease, or stay the same for the following scenarios where chemical reactions take place. A. Exactly 1 pound of bread dough is placed in a baking tin. The dough is cooked in an oven at 350 degrees Fahrenheit, releasing a wonderful aroma of freshly baked bread during the cooking process. Is the mass of the baked loaf less than, greater than, or the same as the 1 pound of original dough? Explain. B. When magnesium burns in air, a white flaky ash of magnesium oxide is produced. Is the mass of magnesium oxide less than, greater than, or the same as the original piece of magnesium? Explain. C. Antoine Lavoisier, the French scientist credited with first stating the law of conservation of matter, heated a mixture of tin and air in a sealed flask to produce tin oxide. Did the mass of the sealed flask and contents decrease, increase, or remain the same after the heating? 25. Yeast converts glucose to ethanol and carbon dioxide during anaerobic fermentation as depicted in the simple chemical equation here. Glucose yields ethanol plus carbon dioxide. A. If 200.0 gram of glucose is fully converted, what will be the total mass of ethanol and carbon dioxide produced? B. If the fermentation is carried out in an open container, would you expect the mass of the container and contents after fermentation to be less than, greater than, or the same as the mass of the container and contents before fermentation? Explain. C. If 97.7 gram of carbon dioxide is produced, what mass of ethanol is produced? 1.3. Physical and chemical properties. 26. Classify the 6 underlined properties in the following paragraph as chemical or physical. Fluorine is a pale yellow gas that reacts with most substances. The free element melts at -220 degrees Celsius and boils at -188 degrees Celsius. Finely divided metals burn in fluorine with a bright flame. 19 grams of fluorine will react with 1.0 gram of hydrogen. 27. Classify each of the following changes as physical or chemical. A. Condensation of steam. B. Burning of gasoline. C. Souring of milk. D. Dissolving of sugar in water. E. Melting of gold. 28. Classify each of the following changes as physical or chemical. A. Coal burning. B. Ice melting. C. Mixing chocolate syrup with milk. D. Explosion of a firecracker. E. Magnetizing of a screwdriver. 29. The volume of a sample of oxygen gas changed from 10 milliliter to 11 milliliter as the temperature changed. Is this a chemical or physical change? 30. A 2.0 liter volume of hydrogen gas combined with 1.0 liter of oxygen gas to produce 2.0 liters of water vapor. Does oxygen undergo a chemical or physical change? 31. Explain the difference between extensive properties and intensive properties. 32. Identify the following properties as either extensive or intensive. A. Volume. B. Temperature. C. Humidity. D. Heat. E. Boiling point. 33. The density, d, of a substance is an intensive property that is defined as the ratio of its mass, m, to its volume, v. Density equals mass over volume. D equals m over v. Considering that mass and volume are both extensive properties, explain why their ratio, density, is intensive. 1.4. Measurements. 34. Is 1 liter about an ounce, a pint, a quart, or a gallon? 35. Is a meter about an inch, a foot, a yard, or a mile? 36. Indicate the SI base units or derived units that are appropriate for the following measurements. A. The length of a marathon race, 26 miles 385 yards. B. The mass of an automobile. C. The volume of a swimming pool. D. The speed of an airplane. E. The density of gold. F. The area of a football field. G. The maximum temperature at the South Pole on April 1, 1913. 37. Indicate the SI base units or derived units that are appropriate for the following measurements. A. The mass of the moon. B. The distance from Dallas to Oklahoma City. C. The speed of sound. D. The density of air. E. The temperature at which alcohol boils. F. The area of the state of Delaware. G. The volume of a flu shot or a measles vaccination. 38. Give the name and symbol of the prefixes used with SI units to indicate multiplication by the following exact quantities. A. 10 to the power of 3. B. 10 to the power of -2. C. 0.1. D. 10 to the power of -3. E. 1 million. F. 0.000001. 39. Give the name of the prefix and the quantity indicated by the following symbols that are used with SI base units. A. C. B. D. C. Gram. D. K. E. Meter. F. N. G. P. H. T. 40. A large piece of jewelry has a mass of 132.6 gram. A graduated cylinder initially contains 48.6 milliliter water. When the jewelry is submerged in the graduated cylinder, the total volume increases to 61.2 milliliter. A. Determine the density of this piece of jewelry. B. Assuming that the jewelry is made from only one substance, what substance is it likely to be? Explain. 41. Visit this Fed density simulation. http://openstackscollege.org/l/16femasvold and select the same volume blocks. A. What are the mass, volume, and density of the yellow block? B. What are the mass, volume, and density of the red block? C. List the block colors in order from smallest to largest mass. D. List the block colors in order from lowest to highest density. E. How are mass and density related for blocks of the same volume? 42. Visit this Fed density simulation. http://openstackscollege.org/l/16femasvold and select custom blocks and then my block. A. Enter mass and volume values for the block such that the mass in kilogram is less than the volume in liter. What does the block do? Why? Is this always the case when mass less than volume? B. Enter mass and volume values for the block such that the mass in kilogram is more than the volume in liter. What does the block do? Why? Is this always the case when mass more than volume? C. How would A and B be different if the liquid in the tank were ethanol instead of water? D. How would A and B be different if the liquid in the tank were mercury instead of water? 43. Visit this FED density simulation. http://openstackscollege.org/L/16 and select mystery blocks. A. Pick one of the mystery blocks and determine its mass, volume, density, and its likely identity. B. Pick a different mystery block and determine its mass, volume, density, and its likely identity. C. Order the mystery blocks from least dense to most dense. Explain. 1.5 Measurement uncertainty, accuracy, and precision. 44. Express each of the following numbers in scientific notation with correct significant figures. A. 711.0 B. 0.239 C. 90,743 D. 134.2 E. 0.05499 F. 1000.0 G. 0.000007388592. 45. Express each of the following numbers in exponential notation with correct significant figures. A. 704 B. 0.03344 C. 547.9 D. 22,086 E. 1000.00 F. 0.0000000651 G. 0.007157. 46. Indicate whether each of the following can be determined exactly or must be measured with some degree of uncertainty. A. The number of eggs in a basket. B. The mass of a dozen eggs. C. The number of gallons of gasoline necessary to fill an automobile gas tank. D. The number of centimeter in 2 meter. E. The mass of a textbook. F. The time required to drive from San Francisco to Kansas City at an average speed of 53 miles per hour. 47. Indicate whether each of the following can be determined exactly or must be measured with some degree of uncertainty. A. The number of seconds in an hour. B. The number of pages in this book. C. The number of grams in your weight. D. The number of grams in 3 kilograms. E. The volume of water you drink in 1 day. F. The distance from San Francisco to Kansas City. 48. How many significant figures are contained in each of the following measurements? A. 38.7 gram. B. 2, multiplied by 10 to the power of 18 meter. C. 3,486,002 kilogram. D. 9.74150, multiplied by 10 to the power of -4 joules. E. 0.0613 centimeter cubed. F. 17.0 kilogram. G. 0.01400 gram per milliliter. 49. How many significant figures are contained in each of the following measurements? A. 53 centimeter. B. 2.05, multiplied by 10 to the power of 8 meter. C. 86,002 joules. D. 9.740, multiplied by 10 to the power of 4 meter per second. E. 10.0613 meter cubed. F. 0.17 gram per milliliter. G. 0.88400 second. 50. The following quantities were reported on the labels of commercial products. Determine the number of significant figures in each. A. 0.0055 gram active ingredients. B. 12 tablets. C. 3% hydrogen peroxide. D. 5.5 ounces. E. 473 milliliter. F. 1.75% bismuth. G. 0.001% phosphoric acid. H. 99.80% inert ingredients. 51. Round off each of the following numbers to two significant figures. A. 0.436. B. 9.000. C. 27.2. D. 135. E. 1.497, multiplied by 10 to the power of negative 3. F. 0.445. 52. Round off each of the following numbers to two significant figures. A. 517. B. 86.3. C. 6.382, multiplied by 10 to the power of 3. D. 5.0008. E. 22.497. F. 0.885. 53. Perform the following calculations and report each answer with the correct number of significant figures. A. 628, multiplied by 342. B. Open parenthesis, 5.63, multiplied by 10 to the power of 2, closed parenthesis, multiplied by, open parenthesis, 7.4, multiplied by 10 to the power of 3, closed parenthesis. C. 28.0 over 13.483. D. 8,119, multiplied by 0.000023. E. 14.98, plus 27,340, plus 84.7593. F. 42.7, plus 0.259. 54. Perform the following calculations and report each answer with the correct number of significant figures. A. 62.8, multiplied by 34. B. 0.147, plus 0.0066, plus 0.012. C. 38, multiplied by 95, multiplied by 1.792. D. 15, minus 0.15, minus 0.6155. E. 8.78, multiplied by, open parenthesis, 0.0500, over 0.478, closed parenthesis. F. 140, plus 7.68, plus 0.014. G. 28.7, minus 0.0483. H. Open parenthesis, 88.5, minus 87.57, closed parenthesis, A all divided by 45.13. 55. Consider the results of the archery contest shown in this figure. A. Which archer is most precise? B. Which archer is most accurate? C. Who is both least precise and least accurate? Archer, W. Archer X. Archer Y. Archer Z. 56. Classify the following sets of measurements as accurate, precise, both, or neither. A. Checking for consistency in the weight of chocolate chip cookies. 17.27 gram, 13.05 gram, 19.46 gram, 16.92 gram. B. Testing the volume of a batch of 25 milliliter pipettes. 27.02 milliliter, 26.99 milliliter, 26.97 milliliter, 27.01 milliliter. C. Determining the purity of gold. 99.9999%, 99.9998%, 99.9998%, 99.9999%. 1.6. Mathematical treatment of measurement results. 57. Write conversion factors, as ratios, for the number of A. Yards in 1 meter. B. Liters in 1 liquid quart. C. Pounds in 1 kilogram. 58. Write conversion factors, as ratios, for the number of A. Kilometers in 1 mile. B. Liters in 1 cubic foot. C. Grams in 1 ounce. 59. The label on a soft drink bottle gives the volume in 2 units, 2.0 liter and 67.6 fluid ounce. Use this information to derive a conversion factor between the English and metric units. How many significant figures can you justify in your conversion factor? 60. The label on a box of cereal gives the mass of cereal in 2 units, 978 grams, and 34.5 ounce. Use this information to find a conversion factor between the English and metric units. How many significant figures can you justify in your conversion factor? 61. Soccer is played with a round ball having a circumference between 27 and 28 inches and a weight between 14 and 16 ounce. What are these specifications in units of centimeters and grams? 62. A woman's basketball has a circumference between 28.5 and 29.0 inches and a maximum weight of 20 ounces, 2 significant figures. What are these specifications in units of centimeters and grams? 63. How many milliliters of a soft drink are contained in a 12.0 ounce can? 64. A barrel of oil is exactly 42 gallon. How many liters of oil are in a barrel? 65. The diameter of a red blood cell is about 3, multiplied by 10 to the power of -4 inches. What is its diameter in centimeters? 66. The distance between the centers of the 2 oxygen atoms in an oxygen molecule is 1.21, multiplied by 10 to the power of -8 centimeter. What is this distance in inches? 67. Is a 197 pounds weightlifter light enough to compete in a class limited to those weighing 90 kg or less? 68. A very good 197 pounds weightlifter lifted 192 kg in a move called the clean and jerk. What was the mass of the weight lifted in pounds? 69. Many medical laboratory tests are run using 5.0 microliter blood serum. What is this volume in milliliters? 70. If an aspirin tablet contains 325 mg aspirin, how many grams of aspirin does it contain? 71. Use scientific, exponential, notation to express the following quantities in terms of the SI base units in Table 1.3. A. 0.13 gram. B. 232 gigagram. C. 5.23 picometer. D. 86.3 milligram. E. 37.6 centimeter. F. 54 micrometer. G. 1 terasecond. H. 27 picosecond. I. 0.15 millikelvin. 72. Complete the following conversions between SI units. A. 612 gram equals space milligram. B. 8.160 meter equals space centimeter. C. 3,779 microgram equals space gram. D. 781 milliliter equals space liter. E. 4.18 kilogram equals space gram. F. 27.8 meter equals space kilometer. G. 0.13 milliliter equals space liter. H. 1738 kilometer equals space meter. I. 1.9 gigagrams equals space gram. 73. Gasoline is sold by the liter in many countries. How many liters are required to fill a 12.0 gallon gas tank? 74. Milk is sold by the liter in many countries. What is the volume of exactly 1/2 gallon of milk in liters? 75. A long ton is defined as exactly 2,240 pounds. What is this mass in kilograms? 76. Make the conversion indicated in each of the following. A. The men's world record long jump, 29 feet, 4 and 1, over 4 inches, to meter. B. The greatest depth of the ocean, about 6.5 miles, to kilometers. C. The area of the state of Oregon, 96,981 miles squared, to square kilometers. D. The volume of 1 gill, exactly 4 ounce, to milliliters. E. The estimated volume of the oceans, 330 million mile cubes, to cubic kilometers. F. The mass of a 3,525 pounds car to kilograms. G. the mass of a 2.3-ounce egg to grams. 77. Make the conversion indicated in each of the following. A. The length of a soccer field, 120 meter, 3 significant figures, to feet. B. The height of mountain Kilimanjaro, at 19,565 feet, the highest mountain in Africa, to kilometers. C. The area of an 8.5, multiplied by, 11-inch sheet of paper in centimeters squared. D. The displacement volume of an automobile engine, 161 inches cubed, to liters. E. The estimated mass of the atmosphere, 5.6, multiplied by, 10 to the power of 15 tons, to kilograms. F. The mass of a bushel of rye, 32.0 pounds, to kilograms. G. The mass of a 5.00 grain aspirin tablet to milligrams, 1 grain, equals 0.00229 ounce. 78. Many chemistry conferences have held a 50 trillion angstrom run, 2 significant figures. How long is this run in kilometers and in miles? 1 angstrom equals 1 multiplied by 10 to the power of -10 meter. 79. A chemist's 50 trillion angstrom run, see exercise 1.78, would be an archaeologist's 10,900 cubit run. How long is 1 cubit in meters and in feet? 1 angstrom equals 1 multiplied by 10 to the power of -8 centimeter. 80. The gas tank of a certain luxury automobile holds 22.3 gallons according to the owner's manual. If the density of gasoline is 0.8206 gram per milliliter, determine the mass in kilograms and pounds of the fuel in a full tank. 81. As an instructor is preparing for an experiment, he requires 225 gram phosphoric acid. The only container readily available is a 150 milliliter Erlenmeyer flask. Is it large enough to contain the acid, whose density is 1.83 gram per milliliter? 82. To prepare for a laboratory period, a student lab assistant needs 125 gram of a compound. A bottle containing 1/4 pound is available. Did the student have enough of the compound? 83. A chemistry student is 159 centimeter tall and weighs 45.8 kilogram. What is her height in inches and weight in pounds? 84. In a recent Grand Prix, the winner completed the race with an average speed of 229.8 km per hour. What was his speed in miles per hour, meters per second, and feet per second? 85. Solve these problems about lumber dimensions. A. To describe to a European how houses are constructed in the U.S., the dimensions of 2x4 lumber must be converted into metric units. The thickness, multiplied by, width, multiplied by, length dimensions are 1.50 inches, multiplied by, 3.50 inches, multiplied by, 8.00 feet in the U.S. What are the dimensions in centimeter, multiplied by, centimeter, multiplied by, meter? B. This lumber can be used as vertical studs, which are typically placed 16.0 inches apart. What is that distance in centimeters? 86. The mercury content of a stream was believed to be above the minimum considered safe, 1 part per billion, ppb, by weight. An analysis indicated that the concentration was 0.68 parts per billion. What quantity of mercury in grams was present in 15.0 liter of the water, the density of which is 0.998 gram per milliliter? 1 ppb Hg equals 1 nanogram Hg over 1 gram of water. 87. Calculate the density of aluminum if 27.6 centimeter cubed has a mass of 74.6 gram. 88. Osmium is one of the densest elements known. What is its density if 2.72 gram has a volume of 0.121 centimeter cubed? 89. Calculate these masses. A. What is the mass of 6.00 centimeter cubed of mercury, density, equals 13.5939 gram per centimeter cubed? B. What is the mass of 25.0 milliliter octane, density, equals 0.702 gram per centimeter cubed? 90. Calculate these masses. A. What is the mass of 4.00 centimeter cubed of sodium? Density equals 0.97 gram per centimeter cubed. B. What is the mass of 125 milliliter gaseous chlorine? Density equals 3.16 gram per liter. 91. Calculate these volumes. A. What is the volume of 25 gram iodine? Density equals 4.93 gram per centimeter cubed. B. What is the volume of 3.28 gram gaseous hydrogen? Density equals 0.089 gram per liter. 92. Calculate these volumes. A. What is the volume of 11.3 gram graphite? Density equals 2.25 gram per centimeter cubed. B. What is the volume of 39.657 gram bromine? Density equals 2.928 gram per centimeter cubed. 93. Convert the boiling temperature of gold, 2966 degrees Celsius, into degrees Fahrenheit and Kelvin. 94. Convert the temperature of scalding water, 54 degrees Celsius, into degrees Fahrenheit and Kelvin. 95. Convert the temperature of the coldest area in a freezer, -10 degree Fahrenheit, to degrees Celsius and Kelvin. 96. Convert the temperature of dry ice, -77 degrees Celsius, into degrees Fahrenheit and Kelvin. 97. Convert the boiling temperature of liquid ammonia, -28.1 degree Fahrenheit, into degrees Celsius and Kelvin. 98. The label on a pressurized can of spray disinfectant warns against heating the can above 130 degree Fahrenheit. What are the corresponding temperatures on the Celsius and Kelvin temperature scales? 99. The weather in Europe was unusually warm during the summer of 1995. The TV news reported temperatures as high as 45 degrees Celsius. What was the temperature on the Fahrenheit scale?